Welcome to Unit 6, Lesson 3. This is part 2 of the video, which is optional unless you miss class. So now we're going to discuss the functions of the liver, which are many. And your liver is this very large organ that is situated in front of your stomach and small intestine. Hiding in behind it there, the little dotted line, that's your gallbladder. And the important components we're going to talk about here are the liver itself and these ducts off the liver. And you'll often hear when people refer to the liver, the fancy term is hepatic. And if you get hepatitis, the reason it's called hepatitis is because it is an infection of the liver. And down here, we have what are called the hepatic ducts. That carry bile to the gallbladder for storage or directly to the small intestine. And once again, SI for small intestine. Now, in terms of function, the liver is often considered the so-called gatekeeper to the circulatory system. As nutrients are digested into the blood, at the small intestine, and then the blood proceeds directly to the liver for processing. And it's here in the liver that the blood will undergo several processes. So there's about 5 key functions with many steps to them. But the functions of the liver include, first, filtering blood, where it actually removes any damaged red blood cells, and recycles their key components. It's also involved in detoxification or detoxifying various substances. So it simply removes toxins from the blood. This means liver cells have extensive amounts of sorry, extensive amounts of what? What's involved, what organelle in detoxifying things? One of them detoxifies drugs. That's your smooth ER. They often have extensive lysosomes and peroxisomes. Another function of the liver is actually storage. So it stores glycogen, which is a medium-term energy store. Whoops, I accidentally closed the file. I could edit that out, but it's not really necessary. Sorry about closing that file there. So glycogen is your medium-term energy store. It also stores a lot of substances necessary for healthy red blood cells. So iron, it stores vitamins, in particular vitamins A, B, and B12. As well, it stores a pool of blood in it, up to approximately 400 milliliters of reserve blood. So if you suddenly need to up your blood pressure, you can get some blood from your liver. And then another function of the gallbladder is secretion. In particular, it secretes bile for fat blank. Starts with an E. You said emulsification, good for you. Which is a form of what type of digestion? Mechanical or chemical? Is it actually breaking the bonds of the fat, or is it breaking it down into smaller droplets? You said mechanical. You are correct. And then the last function is metabolism. But there's really subcategories under metabolism. So the first one is to do with carbohydrates and the regulation of blood glucose levels, which we're going to talk about in detail on the next page. It also is responsible for metabolizing lipids, including making lipoproteins, phospholipids, and cholesterol. And metabolism of, in particular, the breakdown of proteins. which produces urea, which is then filtered out by our kidneys. But it also makes proteins, synthesizes, the fancy word for makes, including two main proteins. One is called fibrinogen, for blood clotting, and the other is called albumin, for regulating blood pressure. And we're going to squeeze this in here. So those are the 5 key functions of the liver, and you really should be aware of all 5, how they work, and if you have any questions, come see me. Now we're going to take a closer look at how the pancreas and liver work together to regulate blood glucose. And what we're going to make here, if we look at the whole page at once, I'm actually going to zoom out, is it's going to make a figure 8 shape. So we're going to start out with the condition of homeostasis, where everything's perfect in our blood and we have balance. So I want you to think about this as a little teeter-totter. And this is homeostasis, where we have balance. And that ideal condition is when our blood glucose levels are approximately 100 milligrams per 100 milliliters of blood. Okay? But sometimes we get out of homeostasis. We either go too high or the blood level goes too low. And our body will try and respond to that to get back to homeostasis. So the situation where we're too low is where either we're exercising hard or we've skipped a meal, something like that. And when we're too low, perhaps we skip a meal, what happens is low, some people just call it low blood sugar, glucose causes pancreas to release glucagon. So glucagon is a hormone. It's going to release it into the blood. And I remember this. It releases glucagon because the glucose is gone out of the blood. You don't have enough. Okay, so when your glucose is gone out of your blood, your pancreas will release glucagon. Glucagon then acts on the liver. Glucagon causes liver to convert glycogen to glucose, thus adding glucose to the blood. and that'll bring the blood glucose levels back up, hopefully to a homeostatic point where it's balanced. But sometimes we go past that point, for example, after we eat a meal, where suddenly we have lots of glucose in our blood. When we do this, when it's too high, it causes, again, this is the pancreas. So, high blood glucose causes pancreas to release insulin. And if these are your tissue cells, insulin causes two things to happen. Insulin causes glucose to move into cells. And remember this, the job of insulin is to move glucose in. Insulin in. That'll take your high glucose blood levels down because they'll move out of the blood and into the cells. As it stimulates vesicles carrying glucose transporters to fuse with the plasma membrane, and now they will transport the glucose in. The other function is it causes liver cells to convert, as the glucose comes in, to glycogen for long-term store, or for next time the glucose is too low. And the combined actions work to lower the blood glucose levels and bring it back down to a balance point. So if you watch this, it really works like a figure eight. We sort of come up and around, or a cycle to keep everything balanced. Okay. If you have any questions about that because you're watching this at home because you missed class, please come see me and I'll help you work your way through it. Now we have to talk about the last key accessory organ. We didn't really talk about the salivary glands because we covered that when we talked about the actual oral cavity, but we might list it then just so we don't forget they are an accessory organ. But here, the last one that we haven't talked about that's in this page hides in behind the liver. It's tucked up in behind the liver. It's like a little sac, and it is the gallbladder. So we have the gallbladder, and then we have these little ductways called the bile duct, which attach into, along with ducts straight, the hepatic ducts straight from the liver, the small intestine. So remember, we had the hepatic ducts where they all meet together. Sometimes it's called the common bile duct. And its functions are fairly simple. It looks funny because we're zoomed out. There we go. Functions are to simply store excess bile from liver. When cholesterol levels are too high, the liver actually processes out the cholesterol and adds it to bile. Now this can have a negative effect on your gallbladder. So, because while your excess bile sits in your gallbladder, over time some of the water in the gallbladder bile is reabsorbed. And the bile becomes more concentrated. And this is typically fine for digestion, but if you have too much cholesterol, what will happen it will actually form gallstones. So it will precipitate out and form like hard little rocks in your gallbladder. And PPT, sorry, stands for precipitate. Okay, so you get these hard little rocks up here in your gallbladder, and sometimes they decide to move and they try and get into this, and then they block the duct, and that's really, really painful. And they have one or two choices. They can try to use ultrasound to smash them apart, or they can go in and actually remove your gallbladder. But that would probably make most of you sad, especially if you like greasy food. Lack of gallbladder means poor fat digestion. So it means you wouldn't be able to sit down and eat a big feed of something like bacon because you wouldn't be able to digest it properly. It would probably give you diarrhea. So, better yet, moderate your cholesterol levels and your fat intake on a daily basis. Don't go extreme all the time, and you'll be able to enjoy it over a longer period of time in your life. So finally, we're just going to look at the regulation of digestion by hormones. There's many hormones involved. We're not going to sort of talk about all of them, but we're going to focus on 4 key hormones. And if you remember, anything like hormones, feedback pathways, these are all ideal for critical thinking questions, as well as looking at the enzymes and what they digest. So we're going to make a little table here. It's going to have 4 columns. The first is going to be the name of the hormone. Then we're going to talk about where it's released from. So we have hormone, released from, or where it's produced, in response to, why do we release it, and the effect, what does it actually do. So one key hormone in our digestive system is called gastrin, related to the term gastric. So where do you think it's released from? If you said the stomach, you'd be absolutely correct. And this is released as soon as we think about food. So in response to thoughts of food. This is why talking about something like this can make your tummy grumble. The smell of food, the sight of food, and the taste of food. You shouldn't have to write food every time. You could just do thought, smell, sight, taste of food. Would have been more efficient on my part. And what happens when you smell food and you're hungry? It actually causes stomach to release gastric juices in anticipation of eating. So the acid and pepsin. In contrast, we have what's also called the gastric inhibitory protein. In short, this is called GIP, gastric inhibitory protein. And it basically does the opposite of what gastrin does. And it's released by the small intestine into the blood, and then it works on the stomach. So it's released in response to acidic chyme entering the small intestine. Because once you've eaten and you've produced chyme and it moves into your small intestine, you should no longer be needing to use gastrin. So it's going to go back and it's going to stop the release of gastric juices. Because at this point you should be done eating. This is the argument, is when little kids eat and people are concerned they're not eating enough, most people will eat what they need to within the first 20 minutes of eating. And by that point, you're going to have a hard time eating after 20 minutes if you pay attention to your body, because it's going to loop back and start telling your stomach to stop producing gastric juices. The next enzyme is called secretin, which is a very appropriate name because it causes the release of a huge amount of secretions. It is released by the small intestine, and it's in response as well. Sorry, typo there. Printo, not a typo. It's acidic chyme entering the SI. So not only do you need to stop the stomach from working at this point, but you need to get the proper juices into the small intestine for digesting. So this causes pancreas to release pancreatic juices into the small intestine so we can begin the digestive process, the chemical digestion. And the last key hormone we're going to talk about, it's quite difficult to pronounce. It's called cholecystokinin. Cholecystokinin. CCK. Okay. Small intestine is where it's released from, and it's released in response to proteins and fats / lipids entering the small intestine. This is how I remember cholecystokinin, because chol sort of comes, the root comes from cholesterol, which is a lipid, and it's released in response to lipids. And it does several things. First, it helps decrease gastric churning. I can't quite squeeze that in there. It helps to cause the gallbladder to release bile, which makes sense because it's released in response to the presence of lipids, so you'll release bile to be able to emulsify those lipids. And along with secretin, also helps signal pancreas to release juices. So those are the four key hormones that we're going to focus on in Bio 12, and their functions in helping regulate the digestive system. Now here we have a picture, and I'm not going to draw this picture for you right now on the video. We're going to work on this in class, and what we're going to try and do is take this table and try a little face up here with a brain. We're going to show how these different hormones affect the other organs. So we're going to show, if you're going to do this on your own, you put the name of the hormone, and if it causes something to happen, it helps it happen, you use a green arrow. And if it stops something from happening, has a negative impact, then you use a red line followed with just a line cutting across it at the end. Okay, so see if you can, if you're doing this at home, summarize this information in a pictorial form. Okay, so that's it for this part of the lesson. If you have any questions, please come see me. Otherwise, I hope you have a great day, and I'll see you in class.